So hi guys, welcome again to another video, and for this video I'll be summarizing the chapter 7, which is the IP. I'll be summarizing again the chapter 7, which is the IP addressing, and let's start. So here is just converting the binary IPv4 address to decimal. Enter the 8-bit binary number of each octet under the positional value of row 1 and then calculate to produce the decimal. It's just an easy way of converting. So here you should memorize the value of positional because it's very helpful, and we'll put the binary number, and if that the positional value has a binary number of 1, so you will just add the binary number which is connected to the positional value. So for example, here we have the 128 and the 64, so we'll just add 128 and 64. So you will be having a 192. So the answer here is 192, so that will be the first value here. It came up with the result 192, and that's just the same as the decimal and binary conversion. You will just add, and if you get the answer, the correct answer, so you will just put their binary number which they connected to. Let's proceed to the next slide. So we have the unicast transmission, multicast transmission rather, and broadcast transmission. So just like from my first video, so the unicast is for 1-to-1, and if you send a message to one PC, so there you will be received from 1-to-1. So for the multicast, so if you send a message to selected user, so that is 1 to 2 or 2 or 3. So for the broadcast, it is 1 to all, so you can send the message through the all users. So that's how the transmission works. So here is for the IPv4 communication. So here it sends a one message to one another. So for the broadcast, it is a 1 to all. So this PC send a message to all the devices that are connected, and for the multicast, it is a 1 to a selected group only. So some of the user will not receive and some will receive the message. So let's proceed to the next one. So the classless addressing. So in this figure, the classful system is allocated 50% of the available IPv4 address to 128 Class A networks excuse me of the addresses to the Class B, then the Class C is shared with the remaining of 25% and with Class D and E. So the problem is that this wasted a great deal of addresses, exhausted the availability of IPv4 addresses. So not all organization requirement fit well into one of these classes. So a company, for example, a company that had a network with 260 hosts and it would need be given to the Class B address with more than 65,000 addresses, wasting 64,740 addresses. So, classless addressing was abandoned in the late 1990s for the newer and current classless addressing program or system. However, there are still classful remains in the network today. And if we assign a IPv4 address to a computer, the operating system examine the address being assigned to determine if this address is Class A, Class B, or Class C. The operating system then assumes the prefix used by the class and makes the default subnet mask assignment. So the system that we use today is the classless addressing. So the formal name is classless inter-domain routing, or what we pronounce as CIDR. So let's proceed to the next one. So we have the IPv4 and IPv6 coexistent. So we have the dual stack, the tunneling, and the translation. And the dual stack allows the IPv4 and IPv6 coexist on the same network segment. So dual stack device run both IPv4 and IPv6 protocol stack simultaneously. For the tunneling, it is a method of transporting IPv6 over the IPv4 network. So the IPv6 packet is encapsulated inside the IPv4 packet, similar to the other types of data. And for the last one, we have the translation, and it allows the IPv6 enabled devices to communicate with the IPv4 enabled device using the translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet and vice versa. So, excuse me. Additional here, understanding the binary notation is important when determining that if two hosts are on the same network, the bits with the network portion of the IP address must be identical for all devices that reside in the same network. So the subnet mask or the prefix is used to determine the network portion of an IP address. IP address can be assigned either statically or dynamically. DHCP enables the automatic assignment for addressing information such as IP address, subnet mask, default gateway, and other configuration information. So I think that's all for this video, and thank you for watching. See you again on my next video.